You gentlemen are at the International School in Hanover?
Yep.
Okay, great. And you're going to be talking about Hydro E, the future of food growth. Sounds very important. So here's the story. This is your presentation. Please go ahead.
Thank you. I'll just present right now. Yeah. So good morning, everyone, and welcome to our presentation. We'll be showing you all about the Hydro CE. This is where we believe innovation begins. So first and foremost, we want to show you our mission statement. This is what drives us. This is what helps us reach our solutions in the way we do. It is to teach and inspire others to take action in solving world problems. In this circumstance, we focused on global goal number 3. This global goal 3 is one of the 17 global goals put forth by the United Nations. And these are all about the betterment of the society and the world. So global goal 3, health and well-being, is all about healthy lifestyles, preventative measures, and increasing life expectancy. Let's introduce our team. My name is Ankur Singh. I'm head of research and electrical.
My name is Mohammed. Thabit. I'm head of build and electrical.
My name is Ihsan. Kisi. I'm head of software development.
We're a small team located in Hanover, Germany, at the International School Hanover region, where we all met and began this project. So now we present to you the Hydro CE. This is a hydroponics controlled environment. We'll show you a fly through right now. So here we grow seedlings and plants of various different types in a soilless environment where we control things like humidity, temperature, nutrient levels, and we'll show you all about a bit more about that later. But here, this is a current prototype that we have developed. So throughout this presentation, we're gonna show you our steps to success. First of all, discovery, how we came to our solution and the problems we identified within the world. Number 2, research and planning, what we needed to learn and how we got our inspiration. 3, transforming the idea, how we brought these ideas into something that could be brought into the real world, and prototyping, our experimentation phase. At the end, number 5, we're going to wrap it all up and talk to you about moving forward and our future aspirations. Discovery, searching for a solution. So the first thing we did as a group was brainstorm what the current issues in the world were, what we thought were big, pressing global challenges. And things that came up were things like world population, rising population meaning rising demand, foodborne diseases, almost 500,000 people die from foodborne illnesses, the greenhouse emissions of agricultural farming and the loss of land due to that, the CO2 emissions from transport, and all of these were things we had mainly covered.
So after thinking deeply about the global challenges faced today and deciding on the issues we wanted to focus on, we started research and planning stage. We believe best way to be inspired is through seeing the inspired. And this urged us to search for the global and local players in the agriculture industry. We started off our research with local communities and entrepreneurs. For example, we have contacted with Urban Farming Aquaponics Hanover, and these people are working on an aquaponics project, an aquaponics system. And if you don't know what aquaponics is basically a combination of aquaculture, which is growing fish, and hydroponics, which is growing plants without soil. Later on, we visited Agritechnica Expo in Hanover, where many industry players came to showcase their products. We exchanged ideas with them, and we saw the talk of the industry. During our visit, we have come across a company called Hyphen, and their disease detection system that was using machine learning was particularly interesting to us. We also found MIT Media Lab's Open Agriculture project with their food computer, and their model of transportable hydroponics was really fascinating. So Hydro CE is a very sophisticated project, and we had to learn a lot. We had to learn from different subject areas such as astronomy, electrical engineering, chemistry, biology, computer science, and visual arts. And just to give you a glimpse of what we have learned, for example, in chemistry, we have learned about the pH levels and learned that they can be an indicator of the nutrients in the water. Or, for example, we have learned about astronomy, where we learned about the wavelengths and the light color.
So the third step in our project is transforming the idea. There are 5 main hardware components of HydroCE, first being the lighting system, the deep water culture system, the air circulation system, the oxygen and carbon dioxide levels in the water, and the nutrient solution. The first system is the lighting system, where we use fluorescent lighting with different wavelengths, because the plant requires different wavelengths in different stages of the growth process. The light system can be automatically controlled, where it switches on for 12 hours and off for 12 hours. We also have an adjustable height system, where we can control the height of the light. We can control the height between the light and the plants, which helps us control the intensity of the light on the plants. The second system is the air circulation system, where we use a distributed air intake and outtake system, and the fan speed can be adjusted, which is important to control the temperature of the environment. As shown in the diagram below, the system is designed in a way so that cold air is sucked in and hot air is pushed out. The third system is the deep water culture system, where in this case, because we're growing plants without soil, we need a water reservoir for the water. And we have on the lid, we have 6 holes with pots, so that the bubbles in the water can touch the plant roots, and so that they can grow longer and absorb the nutrients in the water. We use a black container as a water reservoir to stop external light from coming in, which prevents allergy growth. The fourth system is oxygen and carbon dioxide levels in the water, where we use a water pump to increase oxygen levels in water, which is needed for cellular respiration. And we also control the CO2 levels, which is needed for photosynthesis. We also have an air stone in the water reservoir to help distribute the oxygen intake, which is important so that all plants have bubbles under them. The fifth and final system is the nutrients, where we measure and control the nutrient content of the water in different stages of the growth process. And we do that by using electrical conductivity to measure the nutrients. And we need different amount of nutrients in different stages of the growth process. So a plant in a seedling stage would require a different amount of nutrients than a plant in the flowering stage. And we also control and measure the pH levels of the water, which is important because it affects the nutrient intake for the plants.
All of this can work thanks to our Raspberry Pi. If you don't know what a Raspberry Pi is, it's a small computer that can interact with sensors and relays. And all of the aforementioned sensors and electrical components are connected with our Raspberry Pi. But best hardware is no good if you haven't got a good software. Let me tell you about our software. We have created a software that runs locally on your browser. And this is good for 2 things. First of all, because it is running on a web browser, it is cross-platform, meaning that you can access the software from anywhere, from any of the devices you have, from your phone, from your computer, from your macOS, from your Linux, or from your Windows computer. Also, because it's a web application, in the future, even though right now it runs locally on the machine, in the future it can be deployed to a server, and you will be able to access to the device without actually being connected to it. And I want to also talk about the data visualization libraries and the programming philosophy we took in the software. We have used open source libraries and open source programming languages, and this is good because open source languages are open to everyone. so that people, if they wanted to, they could look into our code, and it makes it more accessible to them. In the sensor testing, you can also see that in the bottom right, we got the sensor testing. You can see our humidity and temperature sensor test run.
So number 4, actually prototyping the idea and bringing it into the real world. So we initially began this project with a rough idea of what we wanted. We knew we wanted a controlled environment. We knew, we needed somewhere to hold the plants. But we began with some very rough sketches, as you can see on the bottom left. And then as we more solidified our idea through research and planning, we developed much more sophisticated sketches that would be more more scalable to our real design. And then we used Onshape to design this in 3D. You can see the adjustable light system that Mohammed was talking about. You can see the Raspberry Pi in the green front, and you can even see the fans on the left and right hand side. And then we began developing this project in real life. As you can see, it had a lot of steps and took a lot of time, but we stuck by it and had a lot of fun along the way until we finally created our very first Hydro CE. We were very ecstatic when we had the project, and we moved our plants and seedlings in as soon as we could. So as you can see, this is the growth period of one of our lettuce patches. And within the second week, we put them into the controlled environment, and they absolutely flourished. The harvest after week 4 was stupendous. It was amazing. And we were so happy about it. We took some very fun photos.
So what is expecting us? What is expecting Hydro CE in the future? We have divided the future of the Hydro CE into 2 categories. We got sustainability and artificial intelligence. Under sustainability, we got energy, and with by energy we mean we are hoping to source the energy of the device by renewable energy sources so that the device is self-sustainable. We also got the fertilization automation. What this means is that during the entire growth, we will have no intervention with the plant. This is good because it will save us time and resources. And moving on to our artificial intelligence part and how we will implement it in the software, we got the real-time plant disease detection system. And this system will basically be able to detect the diseases, warn the user, and give the necessary instructions to ensure the health of the crops. And moving on to the last part, human AI feedback loop that we want to implement into the software. What this means is that we will implement a rating system where the user will be able to rate the crops depending on their properties such as flavor, crispness, and texture. And this data will be supplied back into the machine, and the algorithm will find the best, figure out the best growing environment for that particular plant for that particular user. And we also got our 3 towers of triumph. These towers are really important for us because we will know we succeeded when we reach these towers. Our first tower is creation. We are hoping to create a scalable model that can be used in all sorts of industries, from industrial growing to emergency relief, such as earthquakes. We got the investigation tower, where we are hoping to create an online database that will allow us to do rapid research. And our last tower is the education tower. We are hoping to provide reliable information and tutorials on hydroponic growing to make this knowledge accessible to all.
And here's our very own website that we built, where we post about our progress. We've already posted some blogs about the previous batch of plants that we harvested. And we also post about the research that we conducted and how we built the first prototype of Hydro CE.
So we have presented to you the Hydro CE, a way of growing plants that is more energy efficient, has better yields, and grows plants at a much faster rate. If you want to be part of this agricultural revolution, if you want to be the part of the future of food, please contact us on our You can contact us on our website, our Twitter handle, or our email. You can even go on our YouTube and see videos of how-tos and just pop in to see how we're doing. We want to thank everyone that has helped us along this way: Innovation, Onshape, P2C, and Craft, and Gift. Thank you very much for your time.
Yeah,
Thank you.
The only problem is I'm hungry now.
Perfect.
If you stop sharing, we can see all of you better.
Sorry, stop sharing.
Ah, there you go. There you go. Excellent. Wow. It's very impressive. What was the hardest problem you had to overcome?
If I may, I think the hardest part was, we have so many moving parts within our project. Actually making them work together in the physical sense and making it feasible. For example, since this was, we were trying to incorporate also like the humidity sensors and the software. There wasn't really that much information online of, oh, this is a to-do, this is how you do it. We had to source information. We had to even learn from, for example, as we were talking about chemistry, we had to learn from literal books, and we had to understand the actual science behind it. We had to, we have people specializing in different areas. Ihsan specialized with the software. So we had to really work together to make our project work together.
Great. Dr. Johnson, this is your.
Yep, absolutely fascinating. And oh, wow, if lettuce looked like that, I'd be eating it every day. That is absolutely impressive. And, it really is a testament to your spirit, right? Because I still remember the very first pitch. And my question to you is, how did you guys sustain, the momentum? There was a time when, because the COVID, you can work and, it seemed like the project was going to die an actual death. But I was surprised that you kept it going. So tell us a little bit about how you kept that momentum and the passion.
I think one thing is definitely the nature of this product. Just the fact of putting your seedlings in the machine and watching them grow and seeing the harvest, there's that really rewarding nature of, I guess this works with any type of planting and growth, but you see it growing. And then we always have, I guess the way we work, we always see something that could have been improved next time. We're like, oh, the light system doesn't move up and down that well. Or, oh, the humidity sensor, this could have recorded this better. And if we can make these observations and we can improve the project, I think that's what we're all really striving for. We want to, make a difference. We want to be able to, and that's what was really exciting to all of us. And I think that's what kept it going.
I saw that you had lettuce and did you discover that there were certain plants that did not grow well in this kind of environment?
For example, certain plants we just cannot. For root vegetables, like potatoes, there's not really, we can't just grow them in the water, right? And I guess what this is more efficiently designed for is foods that would not grow in your typical, like, for example, we live in Germany, and we would want to, the aim for the Hydro CE would be to grow tropical fruits or fruits that wouldn't really develop with the weather we have here. Yeah.
But coconuts, probably, you couldn't grow a coconut palm. That wouldn't work.
I mean, there's a thing of science, right?
Like they say never, right? Who knows?
Exactly.
Right? And I think that is the part that I'm most impressed with. You talked a little bit about your team dynamics and how you decided to work as a team. Tell us a little bit more about, perhaps some of the challenges that you might have faced along the way.
Interpersonal challenges.
Yeah.
Well, just one challenge was definitely, as it was during COVID, once we had developed the ideas and the 3D designs, was creating this in real life and the funding for that. So we had to source, we fundraised at our school before COVID did occur. We raised money through things like waffle sales, bake sales. And we presented our pitch to the team at our school, the leaderships team, head of technology, things like that. but that was a definite challenge, you know, because we had to work with the budget, and then as a team we had to decide, as this was our prototype, what do we prioritize? Certain people had ideas, oh, maybe we should focus on the software. Certain people had the idea, maybe we should just get a working prototype and push it first. So there was a lot of compromise along the way and things we had to work with, but we're here at the end.
Now, I know that you are all graduating very soon. In fact, in the next 2 months, which will be very sad for our school. But nevertheless, you know, you have a bright future ahead. How do you see this project growing, or what is your basic next steps beyond after you've graduated?
I mean, we definitely want to present this to more people. We're not quite sure what's going to happen after holidays, after the graduation, like considering where people are going to move. But we definitely, you know, want to keep this alive. We have future aspirations. We have put many hours, lots of blood, sweat, and tears have gone into this, and this is something we all really believe in. You know, we believe that this is an issue that needs to be solved, and I don't see anything stopping us from continuing. Albeit if it has to be online, we all learned these things together. We know how it works, and we can. I believe we can push through distances as well.
Excellent. Most definitely, I see the passion behind the project, but I think you guys have learned so much more, you know, from the knowledge that you've acquired, the skills, you know, the dispositions that are required to work in collaborative teams and so on. So I think this is going to be very sustainable for future projects and new ideas. So, you know, we definitely look forward to you guys coming back, and who knows, in the next 3 to 5 years, we'll be reading about you in Time magazine. Well done.
Here we go. Okay. One last question. Did you notice if the plants grew faster in your environment than they did in a normal environment, because you were giving them everything that they wanted? What kind of speeds were there? I mean,
so if we compared them to soil growing, like for example, what researchers found and what we found, we did for our personal experiences, we did find that they were about 75% faster. The lettuce, we didn't grow side by side, but the database they had on the lettuce we grew, I think it was Lactica sativa, took about 35-40 days, and we had you know, splendid growth within 3-4 weeks. And I'm sure through further optimization, there's been some research into this. Through further optimization, we can get these growth rates much faster and much more efficient.
Wow, very impressive, very impressive. Well, thank you, gentlemen. Thank you very, very much. And Mohammed, you've set a standard now that we're all going to have to rise to, and I'm totally serious, okay?
Thank you.
Congratulations for raising the bar and frankly making the rest of us look bad. But that's
Absolutely. Congratulations, Hydro-C. Well done.
All of you.
Forward.
Good.
Yeah.
Thank you.